All right, we're going to finish up the 3 slides that we did not get to Tuesday. Tuesday we talked about all the little bits and pieces and baby steps of hypothesis testing, and it may or may not have really sunken in what we were doing because it was just the baby steps, the bits and pieces. But today, when we put it all together, hopefully you can see the beginning, the middle, and the end that we talked about. The beginning, remember you have to write the claim in symbolic form and then write what must be true if the claim is false, cleverly called the anti-claim. And then how do you choose between those two? How do you choose which one is the alternative hypothesis? The one that doesn't have the equals in it. It may have less than, it may be greater than, it may be not equal to, but whichever one doesn't have the equals in it, that's your alternative hypothesis. And what does your null hypothesis always have in it? The equals. All right, it always, always, always has equals, no matter what the claim is, no matter what the anti-claim is, no matter what the alternative hypothesis is, the null hypothesis always has equals in it. And that's the beginning. The middle, we didn't really do the middle yesterday because we didn't use the calculator to find a test statistic for us, and we're going to do that today. But Tuesday, we were given a test statistic, and we found its p-value by determining whether the test was one tail or left tail, right tail, or two tail. If it was left or right tail, all we had to do was use normal CDF, either negative 9999 up to some z-score if it was left tail, or z-score to positive 9999 if it was right tail, or if the rejection region was in both ends, if it was a two-tail test, just find the area in one tail and double it because the two tails would have the same area. What did you look at to determine whether the test was one tail, left tail, right tail, or two tail? What was the telling? Which symbol? The symbol where? You're so close. You're picturing it. You just don't have the words for it. In the which hypothesis? Alternate hypothesis. The symbol in the alternate hypothesis told you whether you had a left tail, right tail, or two tail test. Less than was left tail, greater than was right tail, not equal to was two tail. And based on that, you found the area in the rejection region. And how did you use that to determine whether to reject or fail to reject the null hypothesis? What does the p-value, what do you compare the p-value to? In the particular example we did, it was 0.05. What was the name of what that 0.05 was? 2 words. Starts with an S. Significance level. That's the significance level. So you compare the p-value to the significance level, and if p is less than alpha, what did that tell you about the null hypothesis? Reject the null hypothesis, and if p was greater than alpha, what did that tell you? Fail to reject, and I'm glad nobody said accept, because you never accept the null hypothesis. You either say there is enough evidence to reject the null, or there's not enough evidence to reject the null. There's never enough evidence to accept the null. In other words, when you say there's not enough evidence to suggest that this medicine really is helping 70% of the people who take it, you're not saying liar, liar, pants on fire. You're just saying there's not enough evidence. You're going to have to go back and redo this study or something. All right, so those are the baby steps we've talked about so far. The part we didn't get to is after you say reject or fail to reject the null hypothesis, you never end your newspaper article that way, or you never end your broadcast that way, because that doesn't make any sense to the people conducting the study. You have to take your fail to reject or fail to reject the null hypothesis, and then say what that means about the claim being made, in terms of the claim being made. Really, The calculator is going to do the middle part for us. We have to get really, really good at the beginning, setting up the null and alternative hypotheses, and the end, interpreting what the calculator gives us in the middle. All right, so a little bit of practice on interpreting before we do a couple full-blown hypothesis tests. Number 38, this is in 8.2's notes. State the final conclusion in simple, non-technical terms. Be sure to address the original claim. All right, number 38. The original claim is the percentage of on-time U.S. airline flights is less than 75%. That's the claim. Are we making a claim about a mean or a proportion? A proportion. The claim is that the proportion is what? Exactly, P equals 75%. Is that the claim? P is less than 75%, or P is less than 0.75. What's the complement of that? That claim is false if what? Greater than or equal to. Everything that's not less than is greater than or equal to 0.75. So what is your alternate hypothesis? The one of these two that doesn't have the equals in it. The alternate hypothesis would be P is less than 0.75. And what symbol does the null hypothesis always, always, always have in it? P equals. So P equals 0.75. So far, that's the beginning. Now let's play like the calculator did the middle for us, and we decided to reject the null hypothesis. What would that mean? Here's what we're practicing, interpreting this sentence right here, reject the null hypothesis. And I think I mentioned to you Tuesday the sentence that should follow in your brain right after you say reject the null. Reject the null means what? Did I finish that sentence? Accept the alternative. It may have been in my Monday, Wednesday class I finished that sentence. But when you read reject the null, the next thing in your brain always needs to be accept the alternative. So whatever you've written for your alternative hypothesis, that's what the truth is. If you reject the null and you accept the alternative, you're saying there is enough evidence to suggest that P is less than 0.75. Now, that still doesn't need to be your concluding sentence in your newspaper article. P is less than 0.75. Doesn't need to be it. But now that I know the truth or what we've proven, I can say there is enough evidence, or there is sufficient evidence to support the claim. Well, that's going to be noisy. To support the claim, because the alternative hypothesis in this case was the claim. So if we accept the alternative hypothesis, we're also accepting the claim. There is sufficient evidence to support the claim that, and then basically you just restate the claim. The percent of on-time U.S. flights is less than 75%. Your final conclusion is always going to begin with the words, there is sufficient evidence or there's not sufficient evidence. All right? If there is sufficient evidence, What is there sufficient evidence of? If you've accepted your alternative hypothesis and it happened to be the same as your claim, then there's sufficient evidence to support your claim. If this had said failed to reject the null hypothesis, failed to reject always, always, always means not enough evidence to say one way or the other. All right, so we have enough evidence to support the claim here. If I don't know what the goal is, I guess the goal for on-time arrivals would be 100%, or on-times at arrivals or departures. It doesn't say. The percentage of on-time flights, the goal would be 100%, but that's not realistic, you know, because of weather and other uncontrollable factors. The percent of on-time airline flights is never going to be 100%, but maybe somebody thinks 75% is a little bit too low. We should be working towards 90% on-time flights. You never ever accept the null. You either reject the null and accept the alternative, which means there is enough evidence for something, or you fail to reject the null, and that means there's not enough evidence to say one way or the other. So let's do another one. If the original claim is the percent of Americans who know their credit score is equal to 20%, what's the claim in symbolic form? P equals 0.2. That's the claim. Now, almost any time you say proportion is exactly something, there's not going to be enough evidence to support that. I mean, you can say that the percentage of people who know their credit score is less than 20% and be correct, or greater than 20% and be correct, but exactly 20%, that would be hard to hit dead on. That claim is false if what? If P does not equal 2, has to be the complement of the claim. If P is not equal to 0.2. So which one of those two is the alternative hypothesis? The one without the equal to. And what is the null hypothesis? P equals 0.2. Wish he was mowing somewhere else right this minute. This is the beginning. Now let's play like the calculator did the middle for us and came back, failed to reject. When you see the words failed to reject, what word should immediately appear in your head? Not enough evidence or insufficient evidence. Failed to reject always means insufficient evidence. So there is insufficient evidence. And really, if there's insufficient evidence to support or reject. You don't know either way. I'm just going to say insufficient evidence to support the claim. And then just restate what the claim is. Yeah, there's just not enough evidence to say whether or not it is 20%. It may be, but it may not be. Fail to reject always means not enough evidence to say one way or the other. Miss Tony, I meant to pick on you a minute ago because what you said was so true in the lobby a while ago. Tony had gotten 8 out of 9 problems right. And she asked me about number 9 because she had missed it. And I said, where's your picture? And she said, it's the one I didn't draw a picture for. Well, how coincidental is that? The one you didn't draw a picture for is the one you missed. That's how much the picture helps. And writing down, not trying to see in your head. You know what you get from squinting too much, trying to keep everything in your head? These right here, these wrinkles are from trying to do calculus in my head. Stop it, write it down, and look at it to make sure that you have the null and the alternative hypothesis right, because you're going to need to look back at this when you say fail to reject or reject the null hypothesis. You need to have your claim written down so that you can look back at it and interpret what fail to reject actually means or what reject actually means. So write this stuff down. Number 40, the percentage of Americans who believe in heaven equals 90%. All right, what's the claim? P equals 0.9. Makes me wonder if the people who believe in hell is the same percent, or maybe there are people who believe in heaven but don't believe in hell. I don't know. That's an interesting question. But the claim is that P equals 0.9. So what makes the claim false? P is not equal to 0.9. So what is your alternative hypothesis? The not equal to. And what is your null hypothesis? Always equals. P equals 0.9. That's the beginning. Play like the calculator has done the middle for us, and we've decided that we have to reject the null hypothesis. Reject the null, in my head, always needs to be followed by the words except what? Except the alternative hypothesis. So whatever the alternative hypothesis is, you're accepting it. What is the alternative hypothesis? We've proven that P does not equal 0.9. Now, what does that say about the claim? It says the claim is false. Not, we don't know one way or the other, but we have enough evidence to suggest that the percent of people who believe in heaven is not 0.9, so we have enough evidence to reject the claim. Yeah, it's unlikely that the percentage is any one particular exact number. We don't know if, we're not saying that the percentage is greater than 90%. We're not saying that the percentage is less than 90%. We're just saying that the exact percentage is not equal to 90%. Yes. Okay, tell me. I don't remember if you were here last time. Did you miss a class? No. Okay, you were here. Okay, remember, that's okay. That's okay. Tuesday, in some examples, we were given a z-score. It said assume that the z-score is 3.21. Right after we finish 8.2, we're going to see how to get that z-score on the calculator. The calculator is actually going to give us the z and the p and the alpha we're going to compare the P to alpha, and that'll tell us whether to write reject or fail to reject. Yeah, we're just practicing interpreting. We're practicing the middle and the end, and then 8.3 will, no, I'm sorry, we're practicing the beginning and the end, and 8.3 we'll put the middle in there and do the whole thing. All right, this is the only time in any class that I ask you to write a complete sentence. But yes, you really need to understand what it means in terms of the original claim when you say reject or fail to reject, because reject or fail to reject means nothing to anyone outside a statistics class. But if there's a group of people making the claim that the percentage of Americans who believe in heaven equals 90%, and so we poll some people and get a sample and get the sample percentage, then we need to come back to that group and say either yes, there is, you're exactly right, the percentage is 0.9, or there's not enough evidence to suggest that you're right, or there's enough evidence to say you're wrong. That's the three possibilities. Either you're right, you're wrong, or there's not enough evidence to say either way. That's always what reject the null means. Reject the null always means accept the alternative. Fail to reject the null always means insufficient evidence. All right, more examples. If someone makes the claim that the proportion of female students at Roane State is greater than 0.6, Roane State student population is more than 60%. How would you write that claim in symbolic form? What's the claim? It's okay, Tony. Yeah, I already have the symbol in there for you. P is greater than or equal to 0.6. And that's false if the complement of greater than or equal to is just less than 0.6. Nope, equal to can't be in both categories. It's either in the claim or it's in the anti-claim. It can't be both. So what is the alternative hypothesis? The one that doesn't have the equal to. P is less than 0.6. And what's the null hypothesis? Nope. Null hypothesis always has equals. That's the beginning. I'm not going to do the middle here. I just want to figure out what it would mean if the middle indicated that I should reject the null hypothesis. Whatever this p-value is, let's say it's less than alpha, and we write reject the null hypothesis. What would that mean? To accept the alternative, and what's the alternative? The percentage is less than 0.6, and what does that say about the claim? The claim is false. The claim is that the percentage was greater than or equal to 0.6, and we've proven that it's less than. So it does mean there is enough evidence but then you have to say what there's enough evidence for. And it has to be in terms of the original claim. So there's enough evidence to reject the claim. And I'm not going to take time to rewrite the claim here because we need to move on, but there's enough evidence to reject the claim would mean there's enough evidence to tell whoever said the percentage is greater than or equal to 0.6, you're wrong. It's actually less than 0.6. What if we failed to reject the null? What would that mean? What does it always mean? Insufficient evidence to say one way or the other. If I'm talking to the person who made the claim, I'm going to say there's not enough evidence to support your claim. I'm not saying you're wrong. I'm just saying there's not enough evidence to say for sure. Insufficient. Yep. What was the claim? Insufficient evidence to support the claim that what? That's perfect. Yep. So you have to have this written down because reject the null doesn't always mean support the claim. It doesn't always mean reject the claim. It depends on what the null is, what the alternative is, and what the claim is. If the claim is that the proportion of females is greater than 0.6, how would you write that symbolically? P is greater than 0.6. And that's false if P is less than or equal to 0.6. So my alternative hypothesis is the one without the equal to, and the null hypothesis is P equals to 0.6. Now, I don't know if the people who aren't talking to me are thinking in their head, they're saying the answers and just don't want to say it out loud, or if they're just writing down what somebody else says and not really thinking hard about it. If you're just copying down what we write, then when you get home tonight, it's not going to make any sense. So it would be great if you spoke along with your classmates, but at the bare minimum, make sure you're thinking, not just writing down. Writing down what we say is not going to help you here. All right, so what if the middle comes back, reject the null hypothesis? What does reject the null always mean? Accept the alternative. And what is the alternative? This. And what's the claim? That's the claim. In this case, the alternative was the claim. So rejecting the null would mean what about the claim? That it's right. There's sufficient evidence to support the claim. And if we fail to reject the null hypothesis, what does that always mean? Yep. There is insufficient evidence or not enough evidence You could say to support the claim or to reject the claim, but if you're talking to the person who's making the claim, you say there's not enough evidence to support your claim. All right, two more. If someone made the claim that the proportion of female students at Roane State is exactly 0.6, what would that be in symbolic form? P equals 0.6, and that would be false if P does not equal 0.6. So the alternate hypothesis is P is not equal to 0.6, and the null hypothesis is P equals 0.6. That's the beginning. I'm going to do the middle on the calculator, and if we decide that we need to reject the null hypothesis, what would that mean? For reject the null means accept the alternative. But you said insufficient evidence. I may have misheard you. But if you said sufficient, you're right. Reject the null would mean accept the alternative. So there is sufficient evidence to, are we saying accept the claim or reject the claim? If we're accepting the alternative and it's the complement of the claim, then we're saying the claim is wrong. So there's enough evidence to reject the claim. And what does fail to reject always mean? We're not saying you're wrong. We're just saying there's really not enough proof here to say whether you're right or wrong. And if the claim was made that the proportion of female students at Roane State was not 0.6, how would you write that in symbolic form? P does not equal 0.6, and that's false if P does equal 0.6. So the alternative hypothesis is not equal to 0.6, and the null hypothesis is that P does equal 0.6. So if we do the middle on the calculator and it comes back, reject the null, what does that mean? Accept the alternative, and what does that mean in terms of the claim? That is the claim, so there's enough evidence to support the claim. And fail to reject always means there's insufficient evidence. Yes, ma'am. This one? Right here. Okay. Reject the null. Always means accept the alternative. In this case, what was the alternative? No, that's not what we had for alternative. Oh, is that what confused you then? Okay. So we've practiced the beginning. We've practiced the end, and we practiced finding the middle by hand, where we found the p-value with normal CDF. We did that by hand so that you would understand what the calculator's giving you when it says the p-value is 0.2. You need to understand what that is. That's a probability. But from now on, we're going to let the calculator find the test statistic for us, the z-score. We're going to let the calculator find the p-value for us, and then we're going to be given an alpha. We're going to compare our p-value to alpha to decide whether to reject or fail to reject the null hypothesis, and then based on that, we're going to make a statement about the claim. So big thing to remember, rejecting the null means accepting the alternative, and there's two symbols for alternative. It could be HA or H1, but if that's your claim, then you've supported it. But fail to reject always means insufficient evidence. And you could say insufficient evidence to support or reject, but if you're talking to the person who made the claim, you just say there's not enough evidence to support your claim. I'm not saying you're wrong. I'm just saying there's not enough evidence. All right, the entire process I just described is on that last slide, probably in type so small you'll have to get a magnifying glass to read it. But here's the whole process. These first 3 steps are the beginning. Ooh, wow, goodness gracious. Okay, that's a little better. The beginning was identify the claim, the anti-claim, the null hypothesis, and the alternative hypothesis. Those were the steps for determining the null and alternative hypothesis. The middle, you find the significance level. Let's see, right here. This steps 4, 5, and 6 are the middle. You have to identify the significance level. You have to let the calculator find the z-value, the test statistic for you, and you let the calculator find the p-value for you. So you're just going to have to identify the z-value and the p-value from the calculator screen. And then you're going to compare that p-value to the significance level and make the conclusion either reject or fail to reject the null. And then the last step is say what that means about the claim. So steps 7 and 8 are the end. So now we just need to learn one new button on the calculator. We need the button that finds this middle stuff for us. Instead of making a slideshow for today, I liked what I had created in just a Word document. You have to understand the symbols. On that study guide template, remember I gave you a template for everything that should be on the test 4 study guide, so there's no reason for not having what you should have on the study guide. You need to understand these symbols. P sub 0 is the proportion that's stated in the null hypothesis. So if the null hypothesis is the proportion equals 0.5, on your calculator it's going to give you P sub 0. X is the number of successes, N is the number of trials, P is the population proportion based on the claim. The claim may be that the average guy weighs more than 200 pounds. Then the population proportion would be 200. Z is your test statistic. Your calculator doesn't spell out p-value, but that's what P is on the calculator. It's giving you the p-value. P hat is your sample proportion, and alpha is your significance level. These steps are just written form, outline form of this process. So you might like the flow chart. You may like steps 1, 2, 3, 4, 5, 6, 7. They're the same thing. Identify the claim, put it in symbolic form, give the symbolic form of what must be true if the claim is false, identify the null hypothesis and the alternate hypothesis, identify the significance level, and then here's the button we need. On the TI 83 or 84, go to Stat, Test, and if you're making a claim about a population proportion, choose one prop z-test. Now, if the problem says find a confidence interval for the population proportion, what was that button? Find a confidence interval for the population proportion. Last test. That was one prop z int. The prop was proportion and the int was interval. We're not finding a confidence interval now. We're doing a hypothesis test for proportion. So find one prop z test. You have to enter the P sub 0 is the quantity in the claim, the proportion in the claim. X is number of successes out of N trials. Then you have to choose either not equal to, less than, or greater than. That's based on your alternate hypothesis. You pick the symbol that's in your alternate hypothesis so that the calculator knows whether you're doing a left tail, a right tail, or a two-tail test. And then you hit enter, and the calculator gives you some stuff we're not going to use, but the important things that we need are the test statistic and the p-value. You compare that p-value to alpha, and if p-value is less than alpha, you reject the null hypothesis. If p-value is greater than alpha, you fail to reject the null hypothesis, and then you state what that tells you about the claim. So I have 3 examples of the full-blown hypothesis test. In a presidential election poll, 308 out of 611 voters surveyed said that they believed they had voted for the candidate who won. All right? It helps to just stop and picture what's going on here. There's a pollster outside the polls. There's a surveyor outside the voting poll going, do you think you voted for the winner? Now, I have voted in presidential elections where I thought my guy was going to win, and then I have voted where I knew my guy was going to lose. When I voted for Ross Perot, I knew he didn't have a prayer. I just didn't like the other 2 guys. So you're being asked upon coming out of the poll, do you think you voted for the winner? And 308 out of 611 says, yes, I think my guy's going to win. I'm sorry that there's not been a female presidential candidate yet, but that'll change someday. Use a 0.01 significance level to test the claim that among all voters, the percentage who thought that they voted for the winning candidate is equal to 43%. Now, this word percentage here is what tells me to use a proportion test, not a z-test or a t-test, what we're going to be talking about Tuesday. Percentage tells me to use a proportion test. So use a 0.01 significance level to test the claim that the percentage is equal to 43%. Helps to underline your important words. That just draws your eyes right to what's important in that sentence. So what's the claim? That P equals 0.43. That claim is false if what? P does not equal 0.343. So what is the alternative hypothesis? The one that doesn't have the equals in it. And what is the null hypothesis? Always has equals. No matter what the claim is, no matter what the anti-claim is, the null hypothesis always has an equals in it. That's the beginning. Hang on just 1 second. You're one tiny notch ahead of me. What's the significance level we're going to use? 0.01. And now I have everything written down that I need to enter on the calculator in one prop z test. So everybody get to this screen. One prop z test is stat and then test and then number 5. Here's how I decide what to type in. P sub 0 is always the proportion listed in the null hypothesis. So P sub 0 equals 0.43. X is the number of successes. N is the number of trials. In this case, X is the number of people that said, yes, I think my guy will win. N is the number of people who were asked that question. And it's very important that you choose the correct symbol here. You're saying either the population mean doesn't equal 0.43 or it's less than 0.43, or it's greater than 0.3, you always choose the symbol that's in your alternate hypothesis, because that's what's making the calculator get the correct value based on whether this is left tail, right tail, or two-tail test. Since our alternate hypothesis said not equal to, I'm going to make sure I have not equal to highlighted so that the calculator gives me a p-value for a two-tail test. Anyone not have all that entered yet? Number of successes. It's right up, right up here for you, Miss Melissa. All right, so when you hit calculate, here's what you have. Some stuff that you need, some stuff that you don't need. The calculator restates what the alternative hypothesis was right there. The calculator's just telling you, I've done a two-tail test for proportion is not equal to 0.43. The test statistic, Z equals 3.699. Let's just round it to whatever the directions say on the homework, but right here, let's say 1 decimal place, 3.7. Now remember what that Z is, or what the test statistic is. That's how many standard deviations away from the norm that 308 out of 611 voters picking the right, or knowing that they picked the right guy. That's a hard sentence, but yes, Z-score is number of standard deviations that this is away from. If everybody just went in and flipped the switch with their eyes closed, what percent of people, roughly, what percent of people would vote for the winner? If it was just go in with your eyes closed, flip a switch, and there are only 2 guys on the ballot. It'd be 50%. If you just picked with your eyes closed, then there'd be about 50% for the winner and about 50% for the loser. 308 out of 611 actually picked, or saying that they picked the winner is way different than that 50%. So people believed in who they were voting for. They believed they were voting for the winner. The p-value for that test statistic is, now that's the sample proportion. P-hat is 0.5, means 308 out of 611 is about half. That's what p-hat is. P without the hat is your p-value, and is my p-value 2.16 right here? Say no. No, because what? That E means move the decimal 4 places to the left. To do that, I'm going to have to add 3 zeros. 0.0002 if we just wanted 4 decimal places. And is that less than or greater than my significance level? So in step 6, say what that tells you about the null hypothesis. The p-value is what in compared to alpha? It's less than alpha, so does that mean reject or fail to reject? Reject. The significance level, which was 0.01. Correct. So that means reject the null, and reject the null always, always, always means what? Yep, those words are going to be in my head anytime I see reject the null. And then I'm going to look back and see what the alternate hypothesis was. That's why I need to have it written down up here. And here I wrote HA and here I wrote H1, but they're the same thing. I'm accepting that the proportion does not equal 0.43. What does that say about the claim? That means the claim is false. Accept the null hypothesis, and I could put ... That means P is not equal to 0.43. That's just kind of what's going on in my head. But my final conclusion is always going to begin, there is enough evidence or there is not enough evidence. Which one is this? There is enough evidence. There is sufficient evidence. Are we accepting the claim or rejecting the claim? Yep. And what was the claim? That 43% thought they had voted for the winner. Now, after the election, we knew that the winner had actually gotten 43% of the votes. All right. How could there possibly be a winner with less than half the votes? No, there's a legitimate way that a person can be elected president without receiving over half the votes. More than two candidates. Okay. The Republican might get 45% and the Democrat may get 45%, and then there may be Ross Perot getting 10%, but probably not. Ross Perot and my grandpa. So what does that mean about voter perceptions? If the percent who thought they were voting for the winner is not the same as the percent who actually did vote for the winner, what's that saying? This is the hardest question of all. What is that saying about voter perceptions, about what they think? It just means they're not good at predicting the winner. Voters aren't good at predicting who won, because 43% actually voted for the winner, but something other than 43% said they voted for the winner. So, yes, let me write. Let's see, voters' perceptions about the winner voters' perceptions are not accurate. See this P hat right here? P hat is 50%. That means 50% thought they voted for the winner, but actually only 43% did vote for the winner. So folks aren't good at guessing who won. Any questions? Now, I don't know if that seemed easy to you or not up until that very last mind-bending question. Hopefully it did. I mean, hopefully you have the beginning. Where was the middle? The middle was 3, 4, and 5. And the end was 6 and 7. Hopefully you have the beginning, the middle, and the end in your head clearly enough that that didn't seem difficult except for maybe that last question. The only reason that it wasn't difficult, the only reason that I got the right answer was because I had written down all the steps. If I just read that problem, picked up the calculator, and got this screen, I wouldn't know what it meant. If this was multiple choice test and step 7 had an A, B, C, and D to choose from, there'd be about a 25% chance that I'd get the right answer. Because I'd just be guessing if I didn't have all this stuff written down. Please write it down. If you ask me for help, I'm going to say, okay, show me what you've written down. All right, number 2. This is an interesting problem. And it actually says, this is an interesting problem. An interesting and popular hypothesis is that individuals can temporarily postpone their death in order to survive a major holiday or important event such as a birthday. Have you heard that? Or nurses and folks who work in nursing homes, have you ever seen a family say she just wouldn't let go until her son got here? Or she just wouldn't let go until after Christmas because she wanted to be here one last Christmas. So that's the claim, is that people can choose when to let go and when to hang on. In a study of this phenomenon, it was found that there were 6,062 deaths in the week before Thanksgiving and 5,398 deaths the week after Thanksgiving. Now, if people really had no control over whether they died the week before or the week after Thanksgiving, there'd be about the same number before as there was after. So far, so good? In this study, there were 6,000 deaths before and, well, close to 6,000 after. If people can postpone their deaths until after Thanksgiving, then the proportion of deaths the week before should be less than 0.5. Yeah, because if they don't have any control, the proportion would be equal to 0.5. But if people actually are hanging on for Thanksgiving, I want one last turkey leg before I go, then the proportion of deaths the week before Thanksgiving would be less than 0.5. Use a 0.05 significance level to test the claim. Oops, here's the important words. Here's the claim. Claim that proportion tells me I use a population test, not a z-test or a t-test. The week before Thanksgiving is less than 5%. So there's the claim right there. How do I write it in symbolic form? And I may have said 5%, but I meant 50%. Yep. And that's false if P is greater than or equal to 0.5. So the alternate hypothesis is the one without the equal to, and the null hypothesis is P what? Equals. Always, always P equals. What significance level are we given? That's the 0.05. And now I'm ready for the calculator. What am I going to put in for P sub 0 on the calculator? The proportion that's in the null hypothesis, 0.5. What will I put for X? Well, our claim, P, is about the proportion who died before Thanksgiving. So our X has to be the number who died before Thanksgiving. Does that make sense? Yeah, 6062, 6062. If your claim is about percentage who died before Thanksgiving, then X has to be the number who died before Thanksgiving. And what is N? The total, not the number after Thanksgiving, but N is always the total. So add those two numbers and what do you get, somebody? Ooh, I think, yeah, it's even because that's 100. Yeah, it's exactly 1,200. And that 1,200 is nowhere written in that problem. So you have to understand what N stands for to know how to find it. It's the number in the sample. Miss Taylor, what's bugging you? Just it is because that's 6,000 and that's 6,000. I needed one more zero. Thank you. A lot of people were frowning, and that usually means I've messed up. On the calculator, am I going to choose the left tail, right tail, or two tail test? My alternative hypothesis says less than, so I'm going to make sure I have less than chosen. All right. Punch. I didn't mean that there. I meant for that to be right there. Punch that on the calculator. Give me a test statistic to 2 decimal places. Because that's the alternative hypothesis. Remember, P sub 0 is 0.5, and the test is that the population proportion is less than 0.5, and that's exactly what the alternative hypothesis was. Oh, okay. All right. You're just going to choose the less than on your calculator. All right. Anybody have it punched and give me Z to 2 decimal places? Anybody second that? Anybody having trouble getting that? I'll come see what's going on. What would happen? Oop, let me save that question 1 minute. What are you getting for a p-value? Give me 4 decimal places. Anybody second that? 0.8712. That's a probability. What would happen to that p-value if instead of choosing the less than, I had chosen the not equal to? Yeah, 2 tail. It would give me twice the probability of what's in 1 tail. How does that compare to our significance level? Much bigger than 0.05. And since our p-value is greater than the significance level, what does that mean about the null hypothesis? Failed to reject. And what does failed to reject always mean? Insufficient evidence. There is insufficient evidence to what? Okay, there are people that are claiming, or people who believe, folks can postpone their deaths for major holidays, events. So there's insufficient evidence to support the claim. I don't want to finish that sentence that P is less than 0.5. The claim Somebody didn't come to you and say, test the claim that P is less than 0.5. Somebody came and said, test the claim that people actually can postpone their deaths for a major holiday. So that's what we need to say. There is insufficient evidence to support the claim. See you, Miss Darla. Email me if you need me. Support the claim that individuals can temporarily postpone their death I'm just going to say to survive important events. Are we saying that the people who believe that are definitely wrong? No. We're just saying scientifically they don't have proof. But that doesn't mean that they're wrong. It's like the wives' tale on a full moon. If you're close to if a woman's close to her due date on a full moon, they're more likely to go into labor and have a baby on a full moon night than a night that's not a full moon. There's not enough scientific evidence to prove that either, but any nurse who's worked in a maternity ward will probably tell you, there's a full moon tonight, we're going to be busy. Wear your comfortable shoes. All right. One interesting thing about this problem, it's kind of funny, these numbers, there were more deaths the week before Thanksgiving than there were the week after Thanksgiving. What does that mean? About your family gathering. You got it, didn't you? That means I don't want to go again. Okay, last one, number 22. In recent years, the town of Newport experienced an arrest rate of 25% for robberies. So if 100 houses were broken into, there were only arrests in 25% of those cases. The new sheriff compiles records showing that among 30 recent robberies, the arrest rate is 30%. So she says, hey, I'm doing better than the last guy. My rate's higher than the previous sheriff. Is there sufficient evidence to support her claim that the arrest rate is greater than 25%? How do you express that symbolically? Her claim is that P is greater than 0.25. I'm doing better than the sheriff before me. And that's false if P is less than or equal to 0.25. So the alternative hypothesis is P is greater than 0.25, and the null hypothesis is P equals 0.25. What significance level are we going to use? Ooh, actually it doesn't say, and I wanted to tell you this on the homework. If it doesn't, just kind of a rule of thumb, if it doesn't give a significance level, use 0.05. So in the homework, if no significance level is given, use 0.05. Before I grab my calculator, I want to make sure that I have everything identified correctly. What is my P sub 0? 0.25. And that's the percent of robberies for which there was an arrest. So what is X? What does X stand for? Give me words. Give me the words that I typed for you at the top of the front page. number of successes. In this case, success would be arrest in a robbery case. So how many arrests were there? But it gives you what you need to figure it out. In 30 recent robberies, the arrest rate was 30%. How many arrests out of 30 would that be? And how would you find it? 30 times 0.3. There were 9 arrests in 30 robberies. And that is what equals the 30%. How come? Because that's what P sub 0 stands for. It is the proportion stated in the null hypothesis. So P sub 0 is 0.25, X is 9, N is 30, and what kind of test am I doing here? Left tail, right tail, two tail. Where do you look to determine that? Alternate hypothesis is greater than, so I'm doing a right tail test, and I'm going to make sure I tell the calculator that. When you enter that all in one proportion of z-test, what do you get for a test statistic? Give me 2 decimal places. I'm sorry, I missed it. 0.63. Anybody second that?
So we're going to put 0.5.
This and success is an arrest. No, 0.3 is not, look at me just a second. 0.3 is not a number of arrests. Keep looking at me for a second. It's okay. I've had children. I know that you understand better if you're looking at my face. There can't be 0.3 arrest. You can't arrest a third of a person.
Right.
So that's why X is not 0.3. X is the number of arrests out of that 30 robberies. So you have to find 30% of 30. 0.3 times 30 means there are 9 arrests in 30 robberies. You gotta know what X is, and number of successes is not going to be a decimal. All right. What'd you get for a p-value? Give me 4 decimal places. Say it one more time, Tyler. Does anybody second that? Ooh, somebody got something different? Did you have greater than highlighted? You got the z-score right and a different p-value? That would seem to be somebody's got the wrong symbol there. All right, we're going to have to figure out why we're getting different things there. Those add up to give me 1. So somebody has the exact wrong thing. Somebody has less than instead of greater than. Yes, because that's what the alternate hypothesis is. So let me just catch up with you. Stat tests number 5, the sample or the proportion in the null hypothesis is 0.25. The number of successes is 9 arrests out of 30 robberies. And I'm doing a right tail test because that's what's in the null hypothesis. Possibly what happened, somebody may have moved their cursor over but not entered. You got to move it over, then enter to change the highlighting to that. and then calculate, and I got the 0.2635. You hit the less than, oh, okay. Okay, let me go back to what it looked like before I hit enter. Stat test number 5. This is, this is saying the population proportion is not equal to 0.25, or the population proportion is less than 0.25, or the population proportion is greater than 0.25. So all three of these refer to, or in comparison to, the population proportion. All right, so how does that compare to my, that answer is 0.2635. How does that compare to my significance level? Whoops. I don't compare Z to alpha or Z to P. I compare what? P to the alpha. The 0.2635 is greater than my significance level. And what does that mean? Yeah, fail to reject. You do have to have very clear in your head, P less than alpha means reject, P greater than alpha means fail to reject. Now, fail to reject always means what? Insufficient evidence. There is insufficient evidence to support, what's the claim? That the new sheriff that's saying it very well. To support the claim that the new sheriff has a better arrest rate than the previous. Not necessarily previous arrest rate, but just previous arrest rate. We don't know if that previous rate was just from the one sheriff before or for many sheriffs before. Yes.
How do you figure out the greater than sign right here on the top? Greater than.
Are you talking about here? Here? What's your alternative hypothesis? Always the same. All right. No, these two are always the same, but once you get the p-value, you have to look at it and your alpha and say, is it bigger than alpha or less than alpha? It's just a coincidence that that was the same as that. All right. If it made sense, and I pray that it did, but if this made sense, it was because I've broken it down into baby steps for you. To help you practice this process on the homework, I have a tool. Actually, it's a crutch. And so what do you do when you're given a crutch? You use it as long as you have to, and then you throw it away. You don't want to use a crutch your whole life. Here's the crutch. And you're going to love it. It's a gift. It's my spring gift to you.
Your conference is scheduled to end in 2 minutes.
Sheet that you can print, that I've written everything that you need to write. Basically, it's just fill in the blank. It will help you on the homework, but don't rely on this. Don't rely on this and fail to get the steps in your head, because I'm not going to give you that on the test. I'm just going to give you a problem and say, conduct the hypothesis test. Yeah, if you want to put that on an index card, you can, but hopefully you've practiced it enough that you know the process. All right, see ya. Yes. Okay, let me turn